Hello, everyone. This is the makeup lecture for week 7, lecture 7. The first part of the lecture. I'll have 2 parts, a single break. The Zoom is letting me teach more than 40 minutes, so I can, or I don't need maybe 3 times 40 minutes. I'll try to complete as quick as possible this lecture, but I will have a single break. That would be fine, I guess. A single break would be okay for me. I'm waiting for your participation. Hope at least one of you will participate in the lecture, in the makeup lecture. I already made an announcement last week and this week also within the WhatsApp group, and then I was told that you will be accessing the lecture. So I'll wait just for another 2 minutes. It's already 2 minutes gone now. I just accessed 2 minutes late. I'll wait another 2 minutes. If no one shows up, I'll just start the lecture myself, and you watch the recording from YouTube. I will upload the video on YouTube, so you watch it. And I also share with you my lecture notes, and that will be helpful for you as well. Okay, waiting, still waiting. Yeah. It seems, yeah, it's okay, fine. Now I can just start lecturing myself. So if some of you comes, I won't be able to respond for maybe 15 minutes. I'll check sometimes. Okay, a person just show up, one of the students. That's good to see at least one student participate in the lecture. I was just about to start lecturing, Kibra, so I will be sharing my screen. There you go. Okay. It is. Okay, I have prepared this page before I get to the lecture, just to be as quick as possible. In the previous 2 weeks, we also worked out testing the difference between two population means. That's right. We did have the same hypothesis testing in the first 2 weeks ago also, and in the previous week also as well. The first case was when the variances are known, and we use the calculated statistics to set such hypothesis. In the previous week, we have worked out when the variances are not known, but they were equal. They were equal. So they were equal. We were able to calculate the t-statistic with the pooled variance. Remember from the previous week, if I get back to the lecture notes of the previous week, look back. This is with the same hypothesis we're using. Look, they're unknown and they're equal. And I will add this sigma 1 squared equals sigma 2 squared. So if they are equal, you will use the t-statistics, and in the t-statistic, you're not using individual variances. The individual sample variances are pooled. We have a pooled estimate, and we use within the calculated statistics. So you have to calculate this one and then this one to be able to get the calculated statistics. The degree of freedom was n1 plus n2 minus 2, But in today's lecture, so we are having sigma 1 square is not equal to sigma 2 square. What happens if you come across with this situation? In this case, the calculated statistic is also t, but we're not using the pooled variance anymore. We do not need to calculate this value if the variances, sample variances are not equal. Let me show you. Let's see. Okay, look, you're using, right? We're using the individual variances. The pooled variance are not needed here, not required for the calculation of the t statistics. And in the calculation of the statistics, where x1 bar and x2 bar are sample means, s1 square and s2 square are sample variances respectively, and n1 and n2 are the sample sizes, and n1 for the first sample size, and n2 is the second sample size. Okay. The complex thing in this section, in this situation, in this case, is the degree of freedom. In the previous part, in the previous week, we were having the degree of freedom as n1 plus n2 minus 2. It was so straightforward. It's easy to calculate. The calculation is pretty easy, but in this case, the calculation is pretty complex. It's hard to memorize. I know what you're feeling when you see this formula for the calculation of the degree of freedom. But you know, if you practice some exercise, if you work out the exercise I give you, some exercise I will give you, then you will feel that it's easy to memorize. It's not hard. So the other thing is, once you perform the calculation in the examination and you want to make sure whether your calculation is correct or not, you don't want to get back for the calculation. It takes at least a minute of time to recalculate this one. And each time if you calculate, if it's different, so it's trouble. You will have trouble in the examination, so you need to practice. But there is a hint I could give you to understand whether your calculation is incorrect. And this is the hint that the calculation, the result of the degree of freedom in this way would be less than n1 plus n2 minus 2. So you can check, you can use this clue. It's easy to calculate n1 plus n2 minus 2, and you check whether your calculation is smaller than n1 plus n2 minus 2. So you have to check for that. If it's smaller, you're correct. Your calculation might be correct. And the other thing is, you will find the result of the degree of freedom, which is with the decimal point, some decimal places you might have. The t statistics we are using for this course, the degree of freedom are always integers. So this is why if you're not using a statistics software and Excel, you're not allowed to have the degree of freedom with decimal places. So what you do, you will have to round the degree of freedom. The calculation, the result of the degree of freedom should be rounded to the closest integer to be able to use it for a comparison, to be able to get the critical value from the t table. So I always use the t table. So we will be using the same t distribution table. Let me just show you where it is. This one, this is the chi-square. Yeah, that's the t distribution table. Look, the degree of freedom is always integers. You do not have a 22.5, something like this degree of freedom. No, it doesn't exist. So you'll have to round it to the closest integer. So if it's 22.5, you just round it to 23. So you'll use the degree of freedom 23 from the t distribution table. Okay. And the other thing is, we can also construct the confidence interval as well for the mean difference, two mean differences. The difference would be the critical value, And in the critical value, remember, alpha is always half. We always use the alpha level, half of the alpha level, and we do not use the pooled variance here anymore. We use individual variances. So that's the confidence interval, 100 times 1 minus alpha percent confidence interval for the two mean difference, for two mean population difference. Okay. The same hypothesis we have mentioned about those hypotheses in the previous week, and this is left side, left tail, right side, right tail, or double-sided two tail, you can call it. The reason why we call it left tail, because the first mean population will be less in the exercise. In the example, there should be a claim telling you that mu1 will be less than mu2, or it will tell you that, let's say mu1 is female, a representation of female population, and mu2 is a population of male. Then you can tell about the comparison that the female population speak less than male. So if this is the claim, so you're going to represent mu1 for female and mu2 for male. So you will naturally establish the alternative hypothesis where the claim is included will be a left tail hypothesis. And the null hypothesis, it's easy. Once you construct the claim in the alternative hypothesis, then it's easy to construct the null hypothesis as in the opposite direction, because if this is less and this is naturally will be greater or equal. So you can also represent this way. Although I never like this representation, but this is also correct. And so the right side you establish this way, and the left side, and you also have another representation. If you come across such representation in some books, so don't be confused. They're okay. They're not really incorrect. They're correct also. Okay, we may now have, so you would need this one, a degree of freedom, and just try to establish you just draw a picture of the Gaussian distribution picture, and you place your critical value either on the left if it's left side, or if it's right sided you will place it on the right, or if it's double sided you'll have to split alpha into half and determine the critical value from the t table and place one on the left side and one on the right side. The one on the left side will have a negative value. We have mentioned it already in the previous week. And the one on the right side will have a positive value, and which will be symmetric. They are equal. The absolute values, the critical value on the left and the critical value on the right, they're identical. If you just remove the sign, they're identical. Let's have an example. I'll try to fabricate myself an example. I'll try to generate an example. Okay, I have written in Turkish. I'm so sorry. This is an example. I was thinking Turkish, so I have just written in Turkish, the verb in Turkish. Example, I will fabricate myself and one example. A researcher in that female population spend more time on speaking on the phone, more time on the phone than male population. Um, to investigate whether that researchers claim is correct or not. One sample a random sample. Let's say a random sample from female population and another random sample from male population have been selected. Um, their um, their time consumed on the phone has been recorded for both samples and their descriptive statistics are presented as follows. Is there evidence to support the researcher claim with alpha levels, alpha 4.05 level of significance? Construct 100 times 1 minus, that's not 100, just 95% and 95% confidence interval for mean difference, two mean difference. So it will be mu female minus mu male. Okay. So I'll give you the descriptive statistic that are presented. It's just fabrication. I will also use the same result of the result I fabricated in the Turkish section as well. So x1 bar the x1 I'll call just X female, so I'll use the subset female. So let's consider those female from the female population. They speak on the phone daily 72 minutes in average. 72 minutes. And female, let's say the size of that sample from female population, say 21 females are selected. And the standard deviation of the female, let's say, is 30 minutes. 30 minutes. And what about the male population? So I have the X bar for male equals, say, 59 minutes. And the sample size for male, say 18 males are selected, and the standard deviation of the male, say 20 minutes. Okay, I choose integer value just to make the calculation easier. Let me see whether I have a message. No, I don't have a message. Okay, keep going the lecture. All right, I'll get now the solution. For such exercise, you will always need to start with constructing the null hypothesis and the alternative. So if you read back the exercise, the example, the claim is the female population, females are spending more time on the phone for speaking. So it means female, mu female is greater than mu male. So you always start in constructing the alternative first, because where the claim is, and you will easily have the null hypothesis in the opposite direction. So the researcher is telling that mu female is greater than mu male. That's the claim. And the null hypothesis, which is in the opposite direction, which is easily established, mu female is less equal than mu male. And the alpha level is given 0.05. Okay. So all I need is to write the calculated statistic. I can easily calculate the statistic because nothing is unknown for the calculation of these statistics. For this one, it's easy to calculate this one because x1 bar is x1 plus x1 female, and this one x male bar, and s female square, s male square, all are known. So I will try to arrange this formula in terms of male and females, T, and calculated statistics is X bar female minus X bar male divided by S female square divided by N female plus S square male divided by N male. So this is okay. You can modify the calculated statistics in this way. I can substitute the result easily because nothing is unknown. 72 minutes for female, the average of this sample is 72 minus 59 minutes for male, the average 50. So once you see the result of 72 minutes and 59 minutes, you naturally feel that male populations are speaking less on the phone. You will think that they will speak less, but this one from those results, you cannot make up your mind. This is not statistically correct. You can't tell the females are speaking on the phone more. That's not right. Until you perform the t-statistics and complete the statistical analysis, the t-test statistical analysis, then you can make up your mind whether this is correct or not. From just only reading the 72 minutes and 59 minutes, you can't tell that the females are speaking more on the phone. That's true. We don't know yet. Statistically, we have to check. Okay, the variance for the female would be 30 square. That's divided by the size of the sample, which is 21, plus 20 square for the male, and this is divided by their size, which is 18. This is within the square root. Okay. I can easily perform such calculation. If I do this calculation, okay. This is going to be 72 minus 59, and this divided within the square root, 30 square divided by 21 plus 20 square divided by 18. And the result is, my result is, I will have 4 decimal places for the result, approximately 1.6115. I rounded to 4 digits. Okay, I'll box it. Okay, that's the result of the calculated statistics. Okay, the next thing is I would need to calculate the degree of freedom, and then I'll bring the critical value from the t-distribution table and place the critical value on the graphical display and see whether the calculated statistic, where the calculated statistics is falling, whether in the non-rejection area or in the rejection area. So I can make up my mind. The rejection area where you will reject the null hypothesis, and the non-rejection area where you will not reject the null hypothesis. Okay, let's get the degree of freedom as well. The degree of freedom would be, okay, S female square divided by n female plus S male square divided by n male. This is a square. And I also have here S female square divided by n female. This is a square, and this is divided by n female minus 1. And I have another one, S square male divided by n male, and this is a square divided by n male minus 1. Stand it up here. That's the degree of freedom. Okay, I can perform the calculation now. S female, we know already this is 30 square divided by 21 plus 20 square divided by 18. And you will take the square also of this square, and I have 30 square divided by 21, and this is a square, and this is divided by 21 minus 1 plus 20 square divided by 18, and this is the square, and this is divided by 18 minus 1. I know it's scary, the calculation, but if you practice a lot, you shouldn't have any difficulty. But if you use your scientific calculator effectively, and you shouldn't have any difficulty. And another thing is about the examination. Maybe I have mentioned a little about the examination. Midterm examination will be on the 18th of April at 16:30 or 16 something like this, and it will be online. I'll send you the examination paper online. I'll ask you for certain minutes to send me the examination answers, and it will only affect 10% on the whole, only 10% from the midterm examination. 90% will be gathered from the final examination, and the final examination will be taking place in 2 parts. That's what I was told officially. And you might just watch the announcement on the website of Atılım University and to read more about the examination. Okay, let's get this calculation done. Before I get the calculation of this one, I know that the degree of freedom for equal variances was 21 plus 18 minus 2. So that becomes 20, 39, 37. So the calculation of degree of freedom will be less than 37. If you somehow find a value which is greater than 37, and you will easily tell that your calculation is incorrect, you miscalculated somewhere, either from the formula or mistyping or inappropriate usage of calculator. So you'll have to turn back to get the result done correctly. So there is an advantage, of course, in the midterm examination since it's online. You can use Excel, so you won't have any trouble in the calculation. If you use computing facilities, such calculation, it's easy. Okay, I'll do this. I can't remember the result of this one from the 30 section. I'll have to recalculate this back. 30 square divided by 21 plus 20 square divided by 18. And this is divided by 30 square divided by 21. And this is also the square, and this is divided by 21 minus 1. Plus another 20 square divided by 18. This is also square, and that's divided by 18 minus 1. Yeah, my result is 35.0359. Although I prefer using 4 decimal places for fractional values, and in this case I will not use fractional part. I'll have to round it to the closest integer, which is directly, I will call that this is 35. I'll have the result as 35. I do not need to write it as 35.33. Okay, find the critical value. Let's see the critical value. The critical equals E degree of freedom, 35. That will be 35 and 0.05 level of significance. I'll bring this critical value from the T table. So if I get to the T distribution table, you have already learned it from previous weeks. So 0.05 level of significance, this is the second column. So I will need 35 degree of freedom. So I do not have 35 degree of freedom. 34 and 36 is included. 35 is not included. So what I'm going to do is I'll take 34 and I'll take 36 as well and try to average those two values, and then I can use it a representation of for the degree of freedom 35. That's possible. Yes, in this way it's possible. Okay. Yeah. So this doesn't exist. This value is not presented in the T distribution table. We have E 34, 4.05, which is 1.691. And another one, T 36, is included, 4.45. This is also 1.688, as far as I remember. Those are the results for those critical values. Then, what I'm going to do to find, I can approximate T35 with 35 degrees of freedom. So this one would be naturally the average of those two equals T34, 4.05 plus T35, 4.05. And I'm dividing this by 2. And it's easy now. 1.691 plus 1.688. Dividing this by 2, and the result is, I'll get the result for this one. And I think this is going to be easy because I don't need to use a calculator. I can easily tell the average of those two values, 1.69 and 95. I'll have to check. No, mistaken here. 89.5. 9 point. No, not point. No point. Just 5. Okay, that's the critical value. So it has 4 decimal places because the average becomes something else. So it's approximately, that's the critical value. So I'll place it in the Gaussian or the T distribution display. Yeah, there it is. So it's right-sided, the hypothesis is right-sided. So I'll place it on the right side, the critical value, which is 1.68. It'll be somewhere. I'll just place it here. I'll change the color of the pen. The same color. Yeah, there it is. And that's the area where you will tell that the null hypothesis is not rejected. Yeah, the null is not rejected. It's not rejected. Or do not reject the null. And I will tell, maybe that's better to write in this way. Do not reject the null. Not reject the null. So this is 4.05 level of significance. So I determined this value myself, 1.689 and 5. That's the value. And the area where you will not reject the null hypothesis is going to be 0.95. I'm mistaken here. This is the rejection area, actually. Reject the null hypothesis, reject the null right here. So this is the rejection area. Reject the null. So sorry for the mistake here. So this place, do not reject the null. Do not reject the null hypothesis. So in this area. So your calculated statistics is 1.6115. So I can just place it in the position where it's going to be located. So it will have to be located somewhere less than 1. So it will be somewhere here. Okay. Yeah. So that's where you can place it in this area. So it's 1.6115. 1.6115 is somewhere in the area where you will not be able to reject the null hypothesis. So I can write the comments here. Since the calculated statistics result is falling within the area within the non-rejection area rejection area, the null hypothesis cannot be rejected with 0.05 level of significance. So it means actually females are not